Okay, I love the fact that Aiden is pipetting itself as well. No worries. Continue at it.
Sorry. Yeah, sorry. I started this movie. I'm just adding a drug and then I'm done. Sorry about that.
Yes, yes, that's how science should be, you know? Uh, the uh, if I was on a microscope, I would be doing the same thing. Okay, so actually, let's just get started. The spirit of the class is to get stuff done. I will describe a little bit why we are gathering, why we care about what we care about. But as Aiden is showing us, it really is the spirit of the class. At the end of the day, at the end of this course, I want you to walk away having done something that either you had thought that you won't be able to do or had wanted to do but weren't sure, sets of problems that you bother you, that you're excited about, that you haven't had the chance to take on. Uh, so this is a class of a different style. I mean, clearly it's a project class, as I'll describe in a second. But I think it's very important as a spirit. So the fact that that got recorded, Aiden, gives me a lot of happiness. Maybe if we end the class with everybody pipetting or building stuff, I see Daniel has a bike behind him. And, one of the things that's very important is uh, that we are able to bring our full self to the class uh, without changing who you are. Okay, so I think with that as a note, I'll just introduce myself. My name is Manu. I'm a faculty in bioengineering. I also have courtesy appointments in biology and oceanography. I have been on campus for almost 15 years now, and the class is in its fifth year enrolling. We call it Frugal Science. We'll talk a little bit about it. I am actually curious how some of you heard about it, what your expectations and threads might be, what you might have heard about the class itself. Um, what we're trying to go today is I'll describe a little bit, very briefly, on the spirit of the class, why we are here, the logistics, and certain sets of areas clearly in the past of what we have done in the course itself, the philosophy of the class. And then I think I want to turn the tides and I want to hear from everyone in terms of why you might think you're excited about this as an approach. And then I'm seeing Noah, you just joined. We're just doing introductions. And so if you could just turn your camera on, it would be valuable so that people can see everybody. Um, okay, so I think before I start and give you a little bit of a framework for the class, how many of you have heard about this class from other people? I'm just curious. You can just raise your hand, shout out your story of how you decided to take this class. Go ahead, William and Danny.
Yeah, my roommate Peter Allen actually, who's in this course, he found it. I'm not sure how he did, but he told me about it and yeah, it seems really cool, so just wanted to check it out and see what it's
Okay,
about.
Peter, how did you hear about the course?
Really, I was just looking through the course catalog, but I had was familiar with your work on the fold scope and had been thinking about trying to like what impact would really mean with the science we're doing and kind of feeling a little bit alienated in the lab, feeling how distant that was from real world impact. And I think the frugal approach in terms of scaling solutions seems like a good thing to know about.
Hmm. Danny?
Yeah, I'm a first year oceans PhD student, and I've been doing a lot of work with my advisor, Fiorenzo Micheli, and some projects I've been talking about seem to be centered towards ecotech, ecosystem technology. So looking for instruments, devices in other fields that have novel applications in the ocean space, and in particular, if you can do low cost. And I found that you're teaching this quarter, and Theo thought this would be a perfect class for me.
Oh, I'm very happy to hear that. Other people have stories of how they heard about the class. Go ahead. Raghat, I'm also using this as a excuse to learn everybody's name. So if I don't pronounce someone's name, please do correct me. Did I say that right?
No worries. Yeah, that's good.
Yeah, go ahead.
I heard from you last quarter in Med 232, the
Mhm.
Global Health and Scaling class,
Mhm.
And yeah, as a bioengineering student, I was really interested in the opposite side of engineering instead of using very like high technology, very expensive and very inaccessible technology of how we can use engineering to make healthcare more accessible.
Mhm. Okay, who else wants to go next in terms of their story? Rana, go ahead.
Firstly, thank you. You're the first professor who's gotten my name correct on the pronunciation in the 4 years I've been here. So
That
appreciate
might
that a
have to
lot.
do something with I grew up in India for
Yeah, that
22
might have
years
something to
of
do
my
with
life.
that.
Yes.
So, I actually heard about you as a professor in my freshman year because one of my friends, she does some work with nonprofits in India to give access to low income students to lab stuff. So I think she had reached out to you and asked you to get some folder-scopes. And I remember because she called me and she's like, I just got a box of folder-scopes. Like you just gave her a box. There were like 1,000 of them in there. And she was like, I need help carrying it because it's heavy, but this is great. So I'd gone and helped her carry it. So that's how I heard about you and thought I should take a class with you before I graduate.
That is a fantastic story. I have to follow up with her at some point of time. Anybody else has a story of how they heard about the class? I think this is kind of fun as a way to break the ice, but I'm also just curious on um, both people's perceptions and stories and links. So I'm already hearing connections. Any of you know some of the past students? Uh, no? Okay.
I stumbled on the website, the Frugal Science website, and
Mhm.
started watching some of the lectures. That got me excited about the course, especially like the compliant mechanisms
Mhm.
lecture. And I also saw some of the previous projects. And as a kid, I've always built with straws and like toothpicks and cardboard laying around. So uh, it's enticing to see that these tools can be helpful as well.
I think, yeah, that's fantastic. And there is a lot of content, and our goal is going to be is anything and everything we build and learn, we will try to document that on the site. Um, because as you will learn very soon, there will be a cohort of students taking the class with us from around the world. But there is just tons of problem solvers who are tinkering, tackling sets of problems. And I think leaving that content behind for many other folks to actually build upon is very critical. Okay, anybody else wants to share their kind of a quick 10-second story about how they learned about the class? Otherwise, I'm going to jump in and what we want to do. Go ahead, Matthew. Oh, I think Matthew, you are muted. This is a good test because we'll do lots of discussion so people can figure out the tech part as well.
Can you hear me?
Yes, now it's good.
Many years ago, I saw a Mark Rober video, and
Oh,
I saw
that's
it
a
on
long
the course.
time ago.
I saw the name on the course reader or on the course
Yes,
Explore
yes.
courses, and yeah, I was like
I'm
interested.
I'm no Mark Rober, that is for sure. But that video has definitely circulated around. That's funny, actually. I'm glad you brought that up. Um, okay, I think so. First of all, I am delighted that many of you are interested in this philosophy. My hope is that by the end of the course, many of you take this on as another arm of how you think and how you share both your science and a lot of work that you do. I will say this outright. This is a very special year because science is hurting right now. I'm very explicit about it. We will talk quite a lot. Science is hurting in many different ways, both in the context of what has happened over the last couple of months to the entire field of global health. How many of you have heard of USAID? Okay, so everybody's heard of USAID. It doesn't exist anymore in any way and form it used to. There is a lot happening. So I think this class is special. It's particularly special because as scientists, we've always had the responsibility of bringing our science to communities. We do that in many different ways, but there is an explicit sets of ask that I have for all of you, which is to really be able to have a vision for how the sets of things that you want to do, either in this class, outside the class, how it reaches people, and work backwards from there. And that's what we're going to try to do. This class is going to be about scale. And the word frugal just happens to be there because frugal things scale. When you think about cost in a very deep way, it's a very simple economics. You can really reach out to a large number of people. If any of your project in this class reaches 1 billion people uh, in your lifetime, even, that would be a remarkable thing to do. But that's kind of what I want to aspire you to do. And I really mean it. Uh, but you don't start there. You have to think, how would I get there? And so we often use this framework of what I call powers of 10. You start solving a problem for 10 people. When you have gotten that figured out, you solve that for 100 people. You've got figured that out, you go for 1,000 people. How many of you have seen that beautiful video of powers of 10? Do you guys know what I'm talking about? No? Okay, in a few minutes, we will do an interlude. It is such an aesthetically beautiful video that we will talk about it. But anyway, I think one of the key message that I want to share with all of you is this class is about scale. Um, the scale doesn't come accidentally. Scale comes from thinking quite deeply about the problem itself, thinking a lot more about uh, methodologically, how would you approach that problem? How would you break that down? And I think we will talk a lot about certain sets of case studies in which at least, I am still to reach anywhere close to 1 billion people in terms of things that we have done. And so I aspire often enough, and in terms of, Foldscope, for example, is a community of roughly around 6 million users around the world. It's also taken a long time. It's taken 10 years for us to get there, and that's kind of slow. And so often enough, this is another factor to think about is how do you really accelerate some of the adoption? Um, the other point that I want to make is this is going to be a hands-on class. We will do lots of theory, we will do lots of examples, we will spend lots of time in the lab. But at the end of the day, I am hoping that you get your hands dirty and actually tackle a problem. I have no expectations around, oh, we will crack a problem. Any one of you that the problems that we will choose, we will divide up in groups. Uh, that doesn't really matter. But what matters is that we will try an infinite number of times. This is also not a course around grades or anything. I am very upfront about it. You're all incredible people, otherwise you wouldn't be here. So I don't have any intentions of judging any of you in any way and form. What I do have is a level of excitement about what we might be able to do together. So in some sense, we will build teams. Normally, the way the logistics of the course works is really around we have a core Stanford group, and we have around, it depends on number of students, but somewhere of the order of 30 to 40 students spread across the world. And they join in. We divide teams, and teams can have folks from Stanford. You can have students from international collaborators. They can be anywhere in the world. The class is free for anyone to take. This is your chance. If you want to take a class with your brother or sister, this would be the moment wherever they are. You could say, hey, let's do something together. It's perfectly okay to build sets of groups and cohorts that just are passionate about the problem. I think that's the only criteria that matters. Early on, lots of people join, and then slowly some of those sets of teams become strong. But one of the biggest thing that I have taken away for the last 5 years in this course has been the friendships that people have made with the groups that they had from across the world. And that's been really enlightening. And I know many of you grew up in the US, but many of you might have grown up other places. Uh, there might be a problem that you choose that is very specific. Kevin and I just got back from Senegal, and we have lots of friends, and I'll do introductions in a little bit. Not all the TAs are here, and not all the mentors are here. I'll ask them to join once the class is settled a little bit. Um, and so there might be that we would recruit specific sets of mentors for organizations, locations. It's a very context-driven class. So that recruitment task for bringing the right kind of skill set doesn't just lie on me. Any one of you is allowed and actually encouraged to bring friends along. So if Enrico, you have a friend in CERN who you've been thinking about, and oh, this would be a good time to actually do something together, it's perfectly okay. If any of you have a lab mate that has a kind of a skill that you feel that, I have taken on this particular problem, but it would actually be really fun to do this project with another person. Uh, we will all be in charge of kind of building these sets of teams, but at the end of the day, these will be team efforts. Uh, I like the idea of teams not being too large. I'm kind of getting into the mechanics of it in a second, primarily because of just cohesion and making sure that you can take some things on your. So clearly, it won't be a giant team doing one thing. And again, because of the sets of problems, there are so many. We will talk quite a lot about oceanography. Actually, the first 2 weeks will be completely dedicated to oceanography. Uh, we will transition to education and science education being one of the big space. There is a lot of expertise and experience we have in global health. And especially with what's happening now, I think we're going to strengthen and increase the capacity of tackling some of the global health problems. You might choose areas in context around biodiversity. You might be excited about environmental mapping. You can take on a set of a problem that you don't even know where the scientific underpinning of that might be. Uh, and I'll give you lots of examples from past projects. Every year we do roughly between 15 to 20 projects. And that's been consistent over the years. Some of those projects are still open. And it might be that we might take on that specific project and we pick up where we left off last year. Also, you will all be meeting the entire Frugal Science community. Since we've been running this class since 2020, all of the alumni are actually still working, many of them on sets of problems. So Henry, for example, at Stanford started a campaign around new ways of thinking about heating in homeless communities. And that project is continuing and has actually turned into a club on campus at this point. I'll have them come down and I'll have them explain and kind of think a little bit about. But we might also recruit people to actually engage because primarily they might and can also act as mentors. So, uh, this is a much larger community than what you see here. I like to open the first class with a subset of a community because I like the idea of us to get to know each other. Otherwise, the moment I open the floodgates, it'll feel a little bit lost. And so I want you to engage and interact with all the alumni and everything. But at that same time, you are kind of starting on this journey. And so it's actually important to have some amount of cohesion in this team itself. Okay, so that's what I want to say about the philosophical sides of the story. Um, I was going to transition and share a little bit about why we are gathered here. But maybe actually, because what's most important in terms of timing is hearing from you all. Um, Let me just do a quick query to all of you. How many of you already have a a problem space that has bothered you that you really want to take on as a project in this course? I'm curious it doesn't have to be everybody. There is going to be a lot of mechanisms for us to choose sets of projects. But I'm just curious, are people stepping in with already a space that they feel like, it's not right what's happening in the TB space. And I really feel very passionate about it. You don't have to know anything about it. There is a lot of expertise already. All of us will be teaching each other things. This is kind of why I love doing it this way. So anybody who needs to learn pipetting, I'm going to send them to Aiden. I'm already picking on you. And so this is kind of the whole point about skills. Uh, and so in terms of thinking a lot about, but I'm just curious, what percentage of you already have a problem space? Danny already mentioned. Okay, give me 1 second, guys. I might have to choose and change locations. So 10 seconds break, and I'm gonna be back online in 10 seconds. I just have to move locations. Okay, sorry for that interruption. Kids are sleeping right now, so I have to switch. Okay, so I think, yeah, I'm curious. Raise of hands if some of you are just already beaming with a field or a space or something that you feel like, I really want to work in this space. It's important for me to hear it without me tainting your opinions, because it's possible that you might make me think about a space or an area that I wasn't thinking about, and I'll include some of that and I'll kind of bring mentors in that space. I mean, to just give you a sense of the scope of what we have done, in the class, we have worked on low-cost ways of reducing debris in space. So you can imagine that it's a huge challenge if you were to think about what's happening, all the way to we have worked on tracking elephants and reducing conflicts between elephants and farmers in terms of in Tamil Nadu. So anything and everything in that context actually is fair game as long as it's a large enough problem and it's something that you're passionate about. So I am curious if folks have already identified some of these areas. It doesn't have to be a good, clean problem statement. We will work a lot on problem statements, but I'm curious how far we might throw our darts. William.
Yeah, I mean, I don't really have any particular knowledge, but I guess a general theme that I think would be cool to work on for me would be like ocean pollution, plastic sort of stuff, and low cost ways to tackle that.
Mhm.
Um, but yeah, I haven't thought about any like specific projects or really have any particular knowledge about how to tackle that, but I think it'd be cool.
I think ocean is going to be a front and center in the class, and I'm really hoping at least 1/3 or more projects are anchored in the ocean. Um, and we'll talk a ton about plastic for unfortunate reasons. It's something that you cannot escape. Uh, Ragad, go ahead.
I'm really interested in diagnostics,
Mhm,
like ones that are not disease specific and ones that could be like portable or at home.
mhm,
Just thinking about like lack of access to labs and healthcare facilities.
mhm. And I think diagnostics comes up every year. Uh, there is both sets of platforms that I'll be introducing as we go along. And by the way, I think this is an important point to make. There is lots of projects in which we build platforms that then anybody else can build applications on. And so I think this would also be a fair game that you're not starting from scratch. And so, for example, the platform that Kevin and I were testing out in the field is an imaging-based platform now ready to really be deployed very broadly for a large number of diseases. So I think both the platforms that we have built in as a lab, platforms that have existed in the open space, um, and I think, just with what's happening currently in the world, diagnostics has to actually be pretty high up. I'm curious of, yes, go ahead, Gibson.
Thanks, Professor. So, in addition to William and Danny, I'm also have an ocean spend of interest. And you mentioned platforms, and one thing I'm interested in broadly in the ocean is in general, we understand a lot of things about the ocean, either from remote sensing, which is like very spatially resolved and can cover large distances, but doesn't go deep. And then we can do these point measurements that go deep and give us some insight into what's happening down there. But I'm really intrigued in like what we could do from like a volumetric sort of spatially resolved sensing underwater, and to that end, a low cost platform that would allow us to distribute a bunch of sensors over a region so we can understand things spatially.
Mhm. So a couple notes on that. I mean, I think some of you, we do talk quite a lot about Argo floats. We can get access to one of those floats itself. It's by itself quite expensive. There are two or three platforms that, I think there is one that we are building. There are a couple of other friends. I don't know if you guys know about So Far. So Far is a buoy company. They will definitely be as mentors. We will have a few So Far buoys and their latest kind of the bristle mouth, uh,
Mhm.
both power and connectivity that's come online. Uh, I think, I mean, one valuable thread around what you said is our capacity to measure our oceans is really abysmal. It's just astronomically small compared to what we can really do in many other problems. And in some sense, thinking you all will also have a choice. Sometimes we might end up very specifically targeting to say we will design a platform rather than any one specific problem. And that's also okay. It might also that you might choose to make a platform that already exists either much more low cost or just much more useful. Sometimes making something useful itself is also very good because many a times these platforms, nobody else can build applications on top of it. So I heard oceans, I heard diagnostics, any other sets of spaces. I'm curious. And again, I really want to hear before I uh, kind of color people's interest in specific problems. I'm really actually curious how far and wide are people thinking about problems that bother many of you. Yeah, go ahead,
The
Enrico.
One that,
dentist.
Oh,
Oh,
sorry.
sorry.
Go ahead.
I'll go after you.
Okay,
Go ahead.
okay. My uncle's a dentist, and he's talked to me about some of the problems he's faced.
Mhm.
And so I think it'll be interesting to tackle some problems from a frugal standpoint on dental health.
Yeah, I mean, I don't know if you guys know, globally, oral health and oral cancer is one of the biggest rising cancers, and especially South Asia. Massive issue. Almost 15 years ago, we started mapping certain sets of threads around how do we use dentist as a surveillance network for screening for oral cancer. So we have a couple of groups in that space who we have worked with, and again, combining imaging and screening. Uh, I love that as an idea, primarily also because it crosses over and connects with tobacco and cigarettes. We think it's a solved problem. Frankly, it's still one of the most biggest outstanding problems in some sense. And you think about chewing tobacco and many other factors associated with it. Very, very young onset of oral cancer, like 20, 25-year-olds now having oral cancer around the world. Um, so I think the context of dentistry is actually a fantastic one. And again, it might seem like when people talk about many fields, uh, you forget on the periphery, dental care is we take it for granted, and it's actually not ubiquitously available. Rana, go ahead.
Yeah, so for me personally, again, just growing up in India, like school curriculum kind of drives me nuts because you guys will understand this in your freshman year of high school, you have to decide whether you're doing science or business essentially. And if you do business, you like drop all the science classes and just do basically econ and go forward with that. I think
Mhm.
that's extremely impractical in today's world. And yeah, it reduces the potential of a lot of people who may have had a bad like teacher in their eighth grade or something like that from actually realizing how cool science can be. So maybe working on something in science education for me.
Um, yeah, and I think one comment, science education has often been a key theme, starting from actually, uh, you know, we will choose, and I think this is an important point I want to emphasize. You will often hear me talk quite a lot about context and trying to narrow your problem domains. So when we say science education, I'll often ask you, choose a country, choose a region, because you might find that how you might introduce certain sets of things in Kenya are very different from how you might introduce this in Alaska, for that matter, or India, for that matter. And then there might also be common themes, but it's actually very valuable. So you'll hear me asking to focus on subgroups. And those subgroups become very important because they are your anchor point that then you can broaden the sets of problems from. Okay, so I heard about science education. Anybody else that's just dying to share an area that you feel passionate about? Again, you don't need any skills in that space. It just needs to be something that bothers you.
Uh, I would
Go
say
ahead.
broadly, I'm also interested in science education, like making it accessible to low-income communities.
Hmm. And was there a region? First of all, Noe, you have to tell me how to pronounce your name. Is
Oh,
Noe
it's Noe.
Noya?
Noe.
Noya. Okay, I'll get it. Uh, was there a region in mind that you had if you were to?
Uh, I would say, yeah, the US is a like really large country, but I would say like the US in general
Hmm.
and focusing on like lower income communities.
Hmm. Okay, anybody else? Any other areas that kind of broaden out? Yeah, go ahead, Danny.
It's still in oceans,
Yes.
so we've had some of oceans ones, but I think there could be some really interesting low-cost solutions or recovering corals after they've been bleached. That's
Hmm.
kind of approach I'm working on. I think that could be
I
interesting.
love that. I love that. Yeah.
William with plastic, I think that'd be really fascinating. And then also, given that you mentioned you guys had done some tracking for elephants, I think it could be interesting to do some disease monitoring of marine species
Hmm.
through actually tracking them and through reduced movement or increased heart rate. Maybe you could track some diseases.
Hmm. Hmm. Yeah, and I think one of the nice things about ocean plus biodiversity is we have Hopkins as our playground, and it allows us to really test some sets of things very quickly. And simultaneously, there is a much larger network that's really associated with. We have a big partnership with California Academy of Sciences on the coral side and for coral biology. So actually, we have some fairly special coral species. And one day, maybe I should just, it's time for a story. So often enough, I have a habit of telling stories, so let me tell a story. I was shocked by this. One day I was walking in the Cal Academy of Sciences, which I'm hoping all of you, have you all been there? Some of you? No? It's in San Francisco. Really worth going. Beautiful museum, aquarium. They have a tropical aquarium from Philippines and Indonesia, many special species that are very rare. And I was just confused, like, how are you getting all these sets of species? I happen to know the curator for corals and invertebrates there, and we work with them. We've been writing a paper together. So she brought me back door, and then she opened up this massive tank with some of the most beautiful species that I had never ever seen. They were not even on display, and but they were very small fragments. And what she said is that TSA in San Francisco actually catches people smuggling corals into San Francisco. In a year, hundreds of people get caught, and they have a deal that the TSA doesn't toss that coral, that actually goes to Cal Academy. And that's how they've grown. I mean, I was blown away. I was happy that, not happy that people do this, but happy that these coral find home. And then effectively, they kind of anchor in kind of a scientific context. And many of the studies are actually done on them. So it's kind of, I think it's important sometimes when we will. The reason I wanted to make this point is I want you to learn resourcefulness for us to be able to crack and tackle broad range of problems, broad range of interest. We have to think on our feet rapidly, and we have to come up with a minimal, quickest system that can anchor an idea as quickly as possible. And so this is a classic example of resourcefulness. Oh, by the way, we happen to have the most biodiverse coral species somewhere, and what could actually be done? Or when Enrico was saying, oh, I happen to know a dentist, let me just call him, and happens to be my uncle. I'll shadow him for a day. So this resourcefulness is incredibly important. So unlike, you're all doing science, many of you might be doing PhDs or thinking about graduate school, where we align all the stars and then we try working on something. This is the complete opposite. We're going to try to do something as quickly as possible in a problem and then slowly build a much more structured approach to that problem. And so, unless you can viscerally experience it as quickly as possible, it's sometimes very hard to be able to appreciate much more deeply how you can build something. So, again, this is something that is hard to teach, but being resourceful is incredibly important. You know, many of you are at one of the best universities in the world, if not the best. At least we try to compete like that. So that we have no excuse. We have to figure out ways to do things. We have to beg, borrow, not steal, but kind of steal if we need to. But it is important to execute things. As a lab, we have a lot of resources and connections that we have built, but we will also pull upon many other sets of threads. Okay, so I think this kind of gives us a context. I wanted to tell a story. Let me jump in a brief prelude to some logistics. And then I would like a formal introduction where everybody introduces themselves. I'm going to ask you to say a few things. First of all, just introduce yourself. If there is a science problem that you're working on, spend a few minutes describing it. And then also you could talk a little bit about special skills, certain sets of ideas, or a field that you have interest in that you are willing to share. So, but let's do quick round of, actually, should we do introductions first or should we do quick logistics? What do we want to do? You know what? We are kind of already, everybody's seen each other. Let's just do intros. So I'm gonna call on people, and I will give you all time, but I will call on Kevin because I know him well, as a opening. Uh, Kevin, tell us something about yourself, your interest. How do you find yourself on this campus now? And then maybe a few sets of problems that you're excited about.
Yeah. Hey, everyone. My name is Kevin. I'll be the TA for this class, or one of the TAs. I've always
I think
described
we
my
will have three TAs. Kevin is going to be one of them.
I've always described myself as a tool maker. So my background comes with playing with microscopes for many, many months and years. And as I transition to graduate schools, I start thinking about the accessibility of the tools that I build. So last quarter in the fall, I had the chance to join Manu in Senegal, where we had a tool, which is a microscope platform that is able to also act as a diagnostic platform to monitor malaria, but also diagnose them rapidly and in a way that integrates with the workflow that already exists with the primary health centers. So it was very effective, but not in a very disruptive way. Or I guess you can say it's disruptive in a positive way. But yes, tool making to empower people.
And then just as a filler, the platform is called Octopi. You'll hear all about it. You will all get to play. We'll do a case study on what we have built around automated imaging plus AI for diagnostics. Maybe Kevin, you can say a word or two about anything you learned by traveling in Senegal. I don't know if you
Uh,
remember.
yeah, yeah, I learned one phrase at least. Jërëjëf
Yeah.
means thank you. And there's a term in Senegal, it's called Tarangha, which in the United States it's called Southern hospitality. But imagine Southern hospitality for a whole country. So countrywide hospitality and friendliness, where the people assume the best of everybody and are welcoming. So I think that kind of warmth and welcomeness is what makes the country's value so strong and what's made the collaboration with them so delightful, but also what's made it possible to begin with.
Um, and then Kevin spent some time in Senegal with me, and our field site is in Senegal-Mali border. And so, if anybody chooses to work in the space of malaria, clearly this is going to be the core field site that we'll actually choose to talk about. Okay, I'm gonna now just call on people from the top of my screen, and we'll just go in sequence. So, Danny, do you want to go next?
Yeah, hi, I'm Danny. I'm a first year PhD student in the oceans department. I'm working with Firenze McKelly. I'd kind of already talked about ecotech, but I can talk about a specific project that I'm working on right now, which is pretty exciting. And I'm setting up a experiment down at Hopkins actually, where we're looking at coral bleaching. And the whole field of marine science primarily is looking at coral bleaching and how you prevent it. Also, just real quick, coral bleaching. Corals have symbiotic algae that provide a lot of their nutrients. When the water gets too hot, the symbiotic relationship degrades and the corals basically exude and throw out these algae. They then lose their nutrients and they die pretty quickly. And so a lot of the field is looking at how they can prevent coral bleaching, which is really important, but not a lot of looking at once coral bleaching has happened, how can we possibly recover those corals to be healthy again? And so what the project I'm looking at is we're putting them next to healthy corals, and through physical contact, can we possibly reintroduce those algae, those zooxanthellae, into the bleached corals and
Mhm.
possibly down the road have some uh, materials or devices that are colonized with these algae that you can maybe place on these corals that then can recover them.
Mhm.
And then also really interested in marine diseases, and we're looking at how warming oceans and changing oceans are causing marine diseases to be exacerbated and worse. But we also have many more tools in our toolkit, as Kevin says, the toolmaker. We've got a lot more tools in our toolkit in 2025 that possibly could be applied in the marine space to help monitor, surveil, and maybe manage these marine diseases.
And then, Danny, did you say that there are some, you have some cultures in Hopkins
Yes,
for,
so I've got some fragments. I've got some fragments. I've got some bleached fragments and some healthy fragments, and so
yeah,
we've got that going.
yeah. And then do you go back and forth between Hopkins and Marines and main campus?
Yeah, I don't have a car, so I basically just kind of hitchhike a ride with whoever's
Yeah,
going down, and I try to get down there once a week, and then I'll be
yeah.
there this summer for the whole time.
Yeah. And then just as a resource for all of you to know, Stanford happens to have an incredible marine station, and now you know Danny. So next time he's going down, I would highly recommend if you've never seen the marine station, it's about time. Okay, next on my screen is Rena. And by the way, the reason I'm recording this and I'm doing these sets as intros is this would also be the way that many of the other students that will join the class remotely will get to know all of you. So this is important. Rena, go ahead.
Hi, so I'm Raina. I grew up in Mumbai, India. So first-hand experience of like growing up in a community that is maybe 5 years behind the US in terms of science, and then coming here and being like, whoa. I'm doing a dual degree in bioengineering and international relations. And I'm currently working on an honors thesis that focuses on how climate and land use change affects infectious disease patterns in low-income communities. So yeah, my research fundings will be the first to go with everything that's going on.
Mhm,
But yeah, very interested in that space as well as just improving access to science education in underserved parts of the global community.
mhm. And then, Rana, we have a massive network in Mumbai and especially in Dharavi. Um, I was in
Oh,
Dharavi 2 weeks
nice.
ago, and one of the threads is we've worked in Mumbai for almost last 10 years. Um, and did you
Wait,
mentioned
I was in Mumbai 2 weeks ago. That's all.
that's funny. But yeah, I played Holi in Mumbai. So maybe we
Oh,
saw
nice.
each other on the streets. Holi is this crazy festival that I hope you all get a chance to enjoy once. Maybe Stanford Holi is still happening. Rana, you mentioned a word about funding. Has the current sets of threads already impacted any of your current funding? Or you're
It's not
expecting that?
impacted us, but the lab I'm doing this research with
Yeah,
has their funding coming from the National Science Foundation.
yeah.
And so I think Princeton has already lost some money. Columbia obviously has. I think
No, no, no. I mean,
if
Stanford has also lost, I know direct
a lot
examples,
of money, yeah.
lots of them, but it's just, it's useful to know in specific cases and examples, grants that have been terminated. I mean, frankly, just we will do what sets of projects and ideas that people have, and we will find sets of resources to do those projects. I think, from a point of view of resolve, it's very important to think about strengthening the resolve of what you deeply care about. Okay, so Megan,
Yeah, hi. Can you hear me okay?
yes.
Okay. I'm a first year in the PhD in bioengineering here. My background is in soil synthetic biology, so looking at how engineered bacteria survive and spread in soil microcosms. And I'm really interested in continuing to do synthetic biology related to sustainability. So that's what all of my rotations have been in. I'm not quite decided on a lab yet. And I'm also really interested in education as well. I'm working towards the teaching certification here in like equitable and inclusive teaching. And so I also be really interested in projects related to increasing access to education.
And then Megan, can I ask you, can you say one or two more words about the teaching certification on campus?
Yeah, there's this
In
program here
case
called
this might be a chance for you to recruit somebody else here also who might want that.
There's a program here called CERTL. I think it's like Center for like Research, Teaching, and Learning, something like that. I can send a link if anyone's interested. But it's a three-stage program. You take a lot of courses in inclusive teaching and teaching pedagogy, and they have some yeah, courses, but then also ways for you to do hands-on teaching opportunities. And in the end, you get this certification in teaching.
Next on my screen is Jasmine.
Hi everyone, my name is Jasmine. I'm really interested in education as well as communication. I'm on the teaching team for public speaking, ENGR 103, so I've been able to sort of get to explore that passion there.
And then Jasmine, which are you, a graduate student, undergraduate, postdoc, what major?
Yeah, I'm a first year undergrad
Mhm,
and I'm into designing my own major potentially, something at the intersection of business and social impact as well as sustainability. So
mhm,
something like impact management and sustainable engineering.
mhm. And I
And I
think, yeah, go ahead.
was going to say that I found this class in sort of researching about designing your own major because someone had included this in their plan for a designed major.
Mhm. And I think one comment I want to make is you will all see uh, that there is going to be a breadth of members all the way from folks that have just arrived on campus all the way to folks that have people like me who have spent way too much time on this campus that we will admit. And that's the point. So I think I really try very hard to make sure that anybody who is passionate, you will see some of the people that will join in the international community might have 30, 40 years of experience working on a particular problem and they really want to apply that skill to another space. So I think it's very important that we both realize that, and at that same time, that makes me very happy that even the few sets of folks that have given introductions already, you can see the breadth of places where people are coming from. Okay, next on my list is William.
Hey everyone. I'm Will. I'm a second year PhD student in the cellular molecular biology department here. Um, I'm in a lab that studies like speciation in freshwater fish, and hybrid incompatibilities. So that's like generally what I do science-wise. Um, and then I'm also super interested in, like I mentioned, like ocean pollution, also just pollution of like different rivers and stuff like that. I grew up in New York, so we have like a lot of pretty polluted rivers and waterways. So it'd be cool to like, and I know of like a couple nonprofits that do cool things, like trying to clean them up. So it'd be really cool to like spend some time this quarter thinking of like cheap ways that we could like, help get rid of some of the pollution in
Mhm.
those. Yeah.
William, were you ever aware of I don't know, it's called the Million Oyster Project or something Oyster Project in New York?
Yeah. I
Yeah.
think I'm trying to think there's the nonprofit called the Hudson River Project, and they were like, I think pretty involved with that. They were planting all these oyster beds in the Hudson
Mhm.
River. They
Yeah.
also do a lot of cool like education stuff that I think I went to as a kid. And they
Mhm.
do like, yeah, a lot of cool stuff, but yeah.
Yeah, I mean, you remind me one important thing to remember is it's perfectly good as an idea to anchor projects in locations that you have prior context and experience in.
Mhm.
Because although you're not physically there, but you really know and understand the logistics and you can really talk to many people. So that's a
Mhm.
fantastic idea in terms of uh, if you're looking for an excuse to anchor the project in a location, to choose a location that you have lived experiences in.
Okay, yeah.
Okay, next is Peter.
Hi, everybody. I'm Peter. I'm same as Will. I'm also a second year PhD student in the cellular and molecular biology track here. I'm a student in Vayu Helmani's lab. He's a new bioengineering professor who just joined this year. We work on engineering filamentous fungi, so both molds and mushrooms for sustainability broadly. And I'm really interested in waste upcycling, waste valorization, bioremediation generally, whether it's in soil or in waterways. So some kind of low cost projects focus on those things would be very interesting.
And then, Peter, is your lab's cooking kitchen ready? When are you going to invite us for a meal? These
Yeah,
guys are so spoiled. They're going to have a full-fledged kitchen, and I want to know when the next open house is.
I think that the design just got greenlit, so I think we're looking at another year before that space is fully
Ah,
constructed. But
right,
stay in
right.
contact. We'll definitely have an open house.
Okay, next is Aiden.
Hey everybody, yeah, I'm Aiden. I'm in Howard TM's lab here at Stanford, and oh yeah, I'm a second year bio PhD student. And what we study is netosis, which is a process where neutrophils will kind of release their DNA extracellularly in like a web-like structure, and they do that to ensnare pathogens. It's a really cool process. But although it's like been seen to like neutralize pathogens, it can also be a double-edged sword because it's also implicated in sterile inflammation and some cancers. So I'm trying to understand it more, like what's the underlying biophysical mechanism. So then once we understand it, we can then engineer it to maybe not do that in sterile inflammation in cancer contexts. But I think a lot of my research can be super fundamental. And I think I'm trying to take a step back and think, you know, all these techniques are super expensive. How is anybody else going to be able to do it if they don't have the type of uh, uh, techniques or machines that we have here at Stanford, right? So,
Mm.
yeah.
Yeah, and I mean, one thread around this is also microscopy is at a core of a lot of instruments that we have developed. So over the years, Octopi came out as one platform, but there is another platform we'll talk about, which is Squid, where all of you will be building your own completely autonomous microscopes. And Squid is, I mean, some of the papers are online, and we'll have a dedicated sets of sessions. I think thinking a lot more about instrumentation and especially automation and instrumentation. There is I mean, a couple of years ago, those sets of platforms were not that mature. At this point, they have become incredibly mature, and we now have space in the basement of the biology building for teaching people how to build these platforms itself. So I'm really hoping that some of those platforms get used in new projects now. Jack.
Howdy, friends. I'm Jack Riley. Like Peter and Will, I'm a second year in the biology department here. I'm in the Bergman lab, and what I study in the lab context is the cell scale development of leaves and the interaction between that development and the environment, environmental conditions, how that perturbs plant development. I'm from Central Virginia, and in my heart, I'm a summer camp counselor. I think a lot about how really just to get people excited about the beauty of the natural world around them. In the summer camp context, you're just doing that with the bugs and the seeds and the plants that are around you. And I think a lot about, I mean, how a lot of the problems we face come down to people in power having insufficient appreciation for some of the beautiful things around them and how to use some of the tools that we have access to in a research context, how to use those and put them in a context uh, that we can use those to inspire an appreciation for that beauty in other people. But at the end of the day, like getting people excited with plants and bugs. But yeah.
I love that, Jack. And especially you just reminded me of, in some sense, science education is very simple. You just bring the wonder to people and kind of get out of the way, which your
Yeah.
job, the counselor, is to just, as long as people don't hurt themselves and they are having a good time, they are learning. And often we forget about that. Another side comment I want to make, in the Foldscope community, there is a large project right now on mapping the density of stomata in plants around the world. And I know, since Jack works in a lab that does a lot of stomatal developmental biology, as CO2 is increasing, several sets of plants are actually starting to change and put higher density of stomata on their leaves. And so we have a citizen science project that Corey and I've been roping many people in that space. But again, it's, you might think that you're studying something very fundamental and you suddenly realize, wait a second, it's one of the strongest indicators, molecular indicators of what's changing on the climate. So okay, next is Brian. And I have to credit Brian for being the person that made this call possible, because I miscalculated the time. I was there an hour early, and half an hour is what I would have waited. And I would have thought, okay, nobody's interested. Okay, let's shut the laptop down. And then we would not have had this wonderful conversation. So thank you, Brian, for connecting and reminding me to check my phone.
No problem. It was also Megan also messaged me beforehand and was like, is the
I
class
see.
now or
Something is not
10:30?
right.
So also credit to Megan. Yeah, so I'm Brian. I'm a first year bioengineering PhD student. Um my like academic background, I guess, is like biomaterials, mostly for human health applications. So in the first rotation I rotated with Mark Chandler Scott. In the second one I did my rotation with Fan Yang. Um but I guess in terms of this class, my interests are kind of also in science education. When I think about like things that like get me mad in the world nowadays, I think a lot of it also stems with like science education and people broadly not having the opportunities to have the science education early on in life that now lead to people making silly decisions now. I don't know, like anti-vax, cutting science research funding, et cetera. And so I think that combined with the fact that I'm like the son of immigrants who had like basically zero science, like any education really, I think it like hits home uh, like trying to bring science education to those who might not have the opportunity early on in life. So early STEM education is kind of my interest.
And then, Brian, which country, can I ask?
Yeah, sure. My parents were born in Vietnam, but uh my grandparents were born in like China. So my parents are like Chinese Vietnamese, just like a
Mm-hmm,
series of fleeing wars, basically.
mm-hmm, mm-hmm. Okay, next on the list is Enrico.
Hi everyone, I'm Enrico. I'm a first year applied physics student. I'm rotating in Manu's lab, and my interest lies in tinkering. So I like working on cars or bikes and spending times in maker spaces. And something that I've always been wanting to learn, maybe one of you could help me with, is metalworking. So like machine lathing or welding. Yeah.
Mhm. Yeah, I can help you with lathing and welding. I would like to figure out if somebody here does any kind of ring and jewelry design and smelting.
Yeah.
Anyone? That would actually be a fun skill to know. There is a metal furnace, by the way, in the PRL.
Yes, I've heard about that. I want to check it out.
Yes, so Hadil in the lab used to be a TA in PRL, and she can definitely show you how to use the furnace. Okay, next is Matthew.
Yeah, so I'm Matthew. I'm a coterm in Aeroastro. And so in Aeroastro, I come from the stance of like a lot of our stuff is also like really expensive, whatever kind of stuff, but also I kind of have a focus on like aircraft and spacecraft structures. And
Mhm.
in that we try to also do a lot with little, but in the regard of like minimizing material and minimizing weight, because weight is always like our biggest enemy in Aeroastro.
And I'm assuming, I guess, with the coterm, do you have to do a project as well or no?
I am not sure. I
Okay.
don't believe so.
Yeah, okay. Yeah. Okay, next is Raghad.
Yeah. Hello, everyone. I'm Ragad, and I'm a senior in bioengineering. Also, will be doing my co-term in bioengineering. And I'm currently working on a project well, initially I was working a lot in medical imaging, so different kinds, MRI, fMRI, CT. Um, and now I'm working on a project to scale up a rheumatic heart disease screening pilot in Uttar Pradesh.
Mhm,
So that's my current experience.
mhm. And then for folks who don't know, UP is Uttar Pradesh is in India. That's where my hometown is actually. Do you know which city?
It's undecided.
Okay, yeah. Uh, it might be that you might be working in a town that I grew up in. Yeah. And then have you been to UP as yet or not yet?
No, but I'm trying to find a way to visit during the summer when the pilot starts.
I see. Mhm. Next is Daniel.
Hey everyone, I'm Daniel. I'm a first year master's in mechanical engineering. What I'm currently working on at school is a project for building management and trying to reduce carbon emissions for buildings that are already built and aren't super efficient. I'm super passionate about that. And I think kind of more in terms of this class, I grew up in San Diego and kind of grew up with a love for the ocean. So I think doing a project in the ocean space, seeing how much is going wrong there and trying to make an impact in that space would be exciting for me.
Mhm. And then where were you, Daniel, before here?
I went to Berkeley
Mhm.
in undergrad.
Yeah. Sometimes people don't mention Berkeley, huh? Here it's perfectly okay. Okay, next is John.
Hi, everyone. My name's John. I'm a senior and co-term student in bioengineering. Um, I grew up in the Central Valley, California, so like rural California. So I've always been kind of interested in environmental applications of bioengineering. You know, the droughts and like air quality in my hometown are like always a super big issue. Um, so that's kind of what I'm interested in. I've been working in the Deneni lab for a few years. They're a plant biology lab. They focus on like root systems and um, yeah, like plant responses to stress and things like that. And yeah, I'm working on a project in the lab right now where it's not like super directly like environmental like applications of like uh biology or bioengineering, but I'm working on a project where I'm doing kind of a comparative study on different constitutive promoters. That hopefully, so the idea is to hopefully like identify new constitutive promoters that can be used in plant biology research, just so there's like a wider variety of them because there's kind of a limited amount that are currently used.
Yeah, I think I'm very happy to hear that plant biology is represented, and especially soil biology is represented. I think I can clearly see some combinations of people that would talk that would not have talked before. Next is Ryan.
Hello everyone, I'm Ryan. I'm a first year bioengineering PhD student. Research-wise, I'm interested in neuroengineering, which is basically developing methods for studying, treating, restoring function in the brain. More broadly, I'm also interested in STEM education and also democratizing mental health care.
And then Ryan, where were you before coming to campus?
I was in Texas at Rice, so in Houston. Yeah.
Did you spend any time with the Rice 360 program, or do you know about it?
I was aware of it. I didn't personally spend time with it.
Yeah, I think Rice 360 is a fun kind of a program in global health.
Yeah.
I like the history and their links in Malawi, for example. Okay, next on the list is Noya. Noe. Noe.
Yeah, it's pronounced Noe, but it's okay. You can keep
Noe.
practicing.
I think it's gonna take me some time. Noe.
Yeah, no worries. Yeah, so hey everyone, I'm Noe. I'm interested in pursuing a degree in mechanical engineering, but I'm still not sure. I am an undergrad. And broadly, I want to make sure that like solutions that are brought through mechanical engineering are applicable, or at least that lower income communities are exposed to them, especially at younger ages. I related a lot to what other members of the class have said already. So yeah.
Mhm. Yeah, I think I'm very excited. There is a significant resonance on science education, so I'm feeling we should just really run a workshop in East Palo Alto.
Mhm.
Carve out some space, and I'll take you into a classroom. If some of
Yeah.
you have not spent time in a classroom, just I think, some of the learning will happen in our classroom, but some real learning actually happen on the streets and in the trenches. So when you have 30 or 40 10-year-olds yelling at you, that's really when the skills come, the jack skills will have to come out. And it's very, very important to kind of feel the tension and the pressure that many teachers actually feel. Okay, Alexander.
Hello. Um, I'm Alexander. I'm a first year master student in the bioengineering program, and I'm in the same lab as Aiden. So I'm also working on netosis.
Mhm.
I was interested in this class because, or I guess generally the projects I'm kind of interested in are kind of related to the environment and the ocean or water, because I grew up in Boston, and one of the things that left an impression on me since I was young was when we learned about the textile mills that polluted the Charles River. And it's still, that was like a long time ago, and it's still polluted to this day. So, um, kind of things like that are what make me interested in these kinds of things.
Mhm.
Yeah, my background, so for undergrad, I went to Georgia Tech and I studied mechanical engineering.
Mhm.
So, uh, I am interested research wise. I've been doing or trying to learn a lot about like cell engineering, stuff like that. But I still do have an interest in kind of more broad applications. And so that's kind of why I'm here.
Mhm. No, that's fantastic. There are two reasons Charles River, time for another story. Charles River is polluted. One, of course, is the mills that he talked about, but the other is actually MIT undergraduates, because they have a tradition of throwing a sodium from the bridge and let it explode underwater. And one time, the sodium didn't explode. Kevin will have some more details later on. Sodium did not explode and it washed off. And then somebody picked it up and got burned, and there was a massive legal thread, and after that, the tradition of throwing sodium in the river has stopped. Is that half correct, Kevin, or somewhat correct?
This is actually the first time I'm hearing about it.
Oh my goodness, you don't even know this? Okay, I have. All right. So Charles River is infamous because somehow many other things happen, but yeah, it's called the sodium drop, which is very, very bad idea. So there you go. Okay, last but not the least, Aurora.
Hi everyone, my name is Aurora. I am a second year master's student in bioengineering. And shout out to Ryan. I also went to Rice for my undergrad. And then I've done some research in both my undergraduate studies and my graduate studies in tissue engineering, more specifically like using 3D bioprinters to print scaffolds to be like implanted into human bodies to trigger tissue growth. So what I'm like really interested in is maybe like designing some 3D bioprinters, both like hardwares and softwares for both educational and preclinical tissue engineering purposes.
Um, okay, so that concludes, and I'm assuming, did I miss anybody? No, right? Everybody got a chance to. So I think this was important to me because I really feel there's something special about all of you from completely different disciplines. And every year there is a bias. What I love about the fact that I often say about this class that if you're coming from a design background, I want you to take on the challenge of learning how to solve PDEs. And if you're coming from a very engineering kind of a background, I want you to really imagine how to think about problems in a social context. So it's both ways as a street, and I think there is lots of mixed experience. Some of you have experience building and designing projects with activism and kind of a social context as a core. Some of you have incredible technical skills that you've used to build amazing things in the past. But all of you have intent. And that's why this kind of an experiment actually works. It's still an experiment, so don't expect anything or everything will go perfectly. I think the idea is that we will structure the class around quickly cover some use cases and challenges. I'll send you guys all, so just two logistics announcements in terms of thinking about platforms. Uh, I like Canvas, so we'll continue using Canvas for just announcements. But the two communities that are important, one is on Discord, which is the alumni plus the entire Frugal Science community. How many of you have used Discord and are okay and like it? Uh, are okay with it? I'm happy to switch to other places, but now we are stuck with Discord because we started 5 years ago. So some of the alumni that then act as mentors, or sometimes you can reach out because they're spread across the world. So for that reason, it becomes a very active for specific project areas. We seed project areas, and you will see past discussions in those past project areas that you can read through. It's almost an historic archive for the last 5 years that everybody is transparent and open, and you can dive in. So I'll send out logins for that soon with Kevin's help. The second online community is actually on Notion. Let me see if I can share my screen. The sodium drop looks kind of scary, by the way. This is the sodium drop. Um, so I will send out kind of this Notion page. Uh, I'll set up the 2025 page. But one important things there is, there are community guidelines. This is important to understand because we are about to start a project class. So I will read these out. I think it is important that the intent that we have in this class is to really remove barriers to access. And in doing so, we really also have our own commitment. So these are the I think you all know this, but I just want to state it out. These are our rules of engagements. We want to treat everybody respectfully. We have to be inclusive and collaborative. Trust me on this, having done this for a long time. Incredible ideas come from collision of perspectives. So if you sit down with person who doesn't agree with you that this might be the approach, that is exactly where Grace, one of the students in my lab, she's a graduate student, taught me something quite beautiful recently. She was in a class where one of the teachers said that when you're trying to go into new areas and you imagine you have a coffee cup in your hand, uh, and you want to put it on a table, put it in the place of the table where the table is not solid. And the implication was that new things are where there are gaps in our knowledge. We just assume the table is solid everywhere, but how do we know? Maybe electromagnetism doesn't work in a specific area or a location. So what I mean by go places where you feel that something is not right. There is not good sounding and good grounding. And at that places is also where collision of ideas happen. Very important to acknowledge each other in terms of contributions. And I think this is because it's a team project, it's become important. And then, we have to always be striving for broad accessibility. Now, for a lot of projects, the way that that works is I am a strong believer for a lot of my projects in this space. I choose to open source a lot of tools and technologies. It's not a requirement. It's perfectly okay. We will be generating intellectual property. I also file patents on certain sets of things. But for when I'm really thinking about large scale access, I am very supportive and excited about the idea of, and I'm happy we will do a very dedicated sets of session on open source because I want all of you to know and understand the complexity of what's accessible and available in that space. But this will be done with discussions in teams and other factors. So when I share this page will have lots of information. But the most important one that we will build upon is what I've been calling an idea board. And you will notice this is an infinite idea board this is 2023. I can go on to an older idea board. There must be also an idea board for 2024. Uh, and you can see it's organized in different sets of spaces. Many of these problems have still not been tackled or solved. And we will use Notion as a way to organize many of our ideas. It's valuable because there is a kind of a historic context to it that's created. And an important aspect of this is we will use Notion in terms of when teams form, that will be the one place that we will use that as a documentation anchor. We'll use lots of references. That's where our Jupyter collaborative notebooks would be. That's where if you are running a session, so every project will have a ongoing lab notebook essentially. So those are the two. Discord is really for just instant conversations, communication. It doesn't really matter. It's just chaos and you have to just live with it. Notion is really for thoughtful sets of ideas, people working together, kind of starting to structure. We will try to build teams quite quickly. And the reason I sort of do that is even though the ideas are not fixed, some of you will start to gravitate towards the sets of skills you have. And it's okay that then we can hone in. But it's important to be in a team soon enough. So I think after the first 2 or 3 weeks, we would have much of the team logistics figured out. Uh, one more logistics thread around this is, I think another thing around culture. I just want to mention this because I mentioned this too in my lab. I'm sure some of you have heard about this. We're going to kind of use an and culture. And in brainstorming, I like the and culture because if somebody has an idea, I might, at some point of time, the first thing that comes about is 100 ways that's not going to work. But you want to add to the sets of things and kind of creatively expand it. So rather than the but culture, which we are also used to because lots of things don't work, and that's also important, but we'll try to build a little bit of an and culture. So whenever you are engaging, because of course I'm not going to be in all of those sets of conversations, it's very important to build that and remember that often and try practicing it itself. Um, so that was on the social norms. On the logistics side, one important thing that will happen is I will be sending out the announcements, and by Wednesday next week, I would have chosen the cohort of, I would say, between 20 to 30 students internationally that will be joining. I don't know which countries, it's completely open. Sometimes we get hundreds of applications. That's too hard to manage. Sometimes we get 30 or 40 applications. And one of the things that we will do is we will try to structure this in a manner that I will be sending out a form to all of you over this weekend in which the only legal requirement that we have when we teach, and I realize of the time, we will end promptly in 2 more minutes because I didn't realize what is the schedule time, Kevin?
I was pretty sure it was like an hour and a half allotted.
Okay,
Yeah.
anyway, we ended up blabbering for too long. I forget time, so you guys should remind me so that you many of you would have obligations. Last thing I want to say, you will receive a form. Uh, the form is just to show that you acknowledge that there will be other students from around the world taking this class. I teach this class because I feel we should all learn how to solve problems, but I cannot solve problems unless I deeply understand the context of those problems. So I also like to invite many students that are deeply experiencing some of those sets of problems. So if we're working on ocean plastics, I'm going to recruit students from a university in Indonesia, which has the highest plastic biomass on the planet. And then literally when the projects start, they go out on the beach and then they can start measuring and then you really have a team. If we're working on malaria, there will be students from Senegal who will also be anchored and engaged in that format. Yeah, today's class, we will keep it short. So I think the only thing I need from you is when we send that form out, is just an acknowledgement that you are aware that there are other students in the class. This is sort of a legal requirement for Stanford to have external students join in. And again, I vet those students. I know many of them have actually worked with me over the years. They are partner organizations. Many of them run NGOs around the world. So, I have a sense of trust. But at the other end, it's also important for paperwork purposes that people are aware.
Quick
Rana had a
question.
question. Let's now is the open mic time. At the end of every class, we have an open mic. Anybody can say anything and ask anything. So Rana, you have already opened the open mic. Go ahead.
Okay, that's great. I think I was looking at the Notion pages and they mentioned there was lab sessions on Fridays. So
Yes.
just that wasn't on what do you call it? Like the course navigator or
Yeah, I
Scopus. So just
hadn't put it
wondering.
this time because so I have booked the room and we have space available and time available. As the projects will develop, over the couple of years, we used to have a session that's dedicated. And what I've realized is that it's been a free for all. People end up not just coming during that time. You can actually come anytime. You're going to have 24/7 access to the lab space, and we will have storage and we will have some amount of project space. Everybody will also have a budget for the projects. So this year, what I decided to do is rather than force that at a time, I've just opened that up. I will be present on Fridays for that time slot. If people want to spend lots of time with me in the lab, that's the place to find me. But I also don't want to curtail. Sometimes people find that, oh, working in evenings is better for them. Groups will decide. So I think I kind of removed that officially as a requirement because then it was clashing with many people's calendars sometimes. But if you want, I mean, of course, I'm also around other times too, but Fridays, and especially it will really pick up when the project sessions begin. Because the way we will structure the class is one class, every one will be much more of a lecture, deeply diving into the problem and sharing the tools. And then the other one will really be a hands-on session on a platform that exists that can be built upon, or you just learn how somebody else solved the problem. And then we will go back and forth. So think of that really. One is anchored in theory. We will actually do a whole bunch of optics theory. We will do some applied math. I will definitely do my classic Fermi's problems, which some of you in physics have been exposed to, but many others, which is here is a homework assignment for tonight is estimate the number of piano players in New York. Uh, these are called Fermi's problems. It's important to really live by numbers and understand how many microplastic pieces are there in the total volume of the ocean. And so we will go through this very structured in a manner so that you have all the sets of tools associated with it. But if you want to start thinking about these types of problems, because we will use this framework that's called by the numbers. So we'll go back and forth. Officially, there is no session that's on Friday. Friday is really the tinkering day. I want to see if we just open it, how many of you will like to hang out with all of us tinkering. But I also don't want to make it a requirement because I felt for some students it was becoming difficult. I think time slot for Friday. What time would people like? I'm happy to do whatever people like. My group meeting is on Friday from 10 to noon. Depending on what people choose, I will change my group meeting time for this quarter. Um, should we say, is 9 too early? Actually, 9 is a little too early for me to make it. Uh, let's do 10 to 12 for people that want to hang out. And you can make suggestions as well. We can make suggestions and choose a time that's a happy time for everybody. I think evenings is also okay. So if people want to feel an open-ended evening time, we can also do something like 5 to 7 as a tinkering time. I mean, when projects come about, you guys will have to carve time to be able to do stuff. So there is a tension between choosing. So keep your Fridays open in that regard. And again, some teams might gravitate towards working on a different day, for example. Any other questions? This is now the open mic time, and I'm going to give you a half an hour back today. Any other questions?
I just want to bring something up or field a question. Would it be helpful if everyone shared like a few sentence profile and I can post it on the Notion or something so that people can see what everyone's up to in order to facilitate team formation?
I love that as an idea, and I think it's just also people's Slack ID, Discord, and I think this video is there. But if folks want to just write a funny slash slightly serious bio, we can post that. And I want to also post that on the Frugal Science class website because this is also how people will find you when we bring the international students as well or collaborators broadly.
And something that to elaborate on, when we do bring the international cohort in, are Stanford students able to collaborate with them, or what's the dynamic
Oh,
on?
absolutely. No, no, no. Once they are in, I just like to do this first as a core group. Uh, but then after that, everybody is a student, everybody is a teacher, anybody can work with anybody. It is actually really fun sometimes when you choose somebody in a totally different time zone that have certain sets of resources that you don't have. It kind of is 24/7. And I think some of the best friendships I have seen have happened that way. But also, if William and Peter are seeing each other every lunch, it's not a bad idea to work together, right? Maybe, it's so there are no biases around. You guys can choose which way you structure it. But the purpose is that uh, I think most often the problem insights and the kind of constraints become really clear when you also have students far and wide. And, I think typically, I don't know why, it's because of past traction. Have lots of students from Germany, lots of students from Europe, India, definitely, Indonesia, because we have a big network in Indonesia, Latin America, students join from Peru. If you have a country in mind, if you ever work with an institute, I will send out the advertisement tonight. So you can also pass that forward. Like Brian, if you happen to know an institute in Vietnam and you felt, oh, I would like some students from there if they were to join. And again, there is a commitment to this course. This is not an easy class because we're trying to do something, and doing something is always hard. So it's just given by this is not a class that you watch from the sidelines, because the breadth of what we want to cover and for a breadth of what we want to execute, it's really driven by the desire to do something. The end goal doesn't really matter. So many of the students that join in, I do have a conversation with them if they are committed to it. And, I think many a times that's really the strongest indicator for successful team projects is when the degree of commitment is very strong, especially if the problem that they agree on is something that truly bothers them. And frankly, when I think about what's happening currently in the country, I feel very strong. I wish I had the capacity of we could run like a 500 people class, but we just can't. It breaks down after some time. But just with the number of things that are unfolding in front of us, we have to accelerate what we do. Okay, so that was a long-winded answer. Anybody last parting thoughts? I'm gonna give you your half an hour back. Any open mic?
Yeah,
Go
if
ahead,
you want to
Enrico.
suggest the course to friends and family, should they email you directly, or is that probably written in the advertisement?
It will be in the advertisement. We will set up a Google form, and all they have to do is just do a two-liner. Uh, and I can already tell you, I accept everybody. But I do have a conversation with everyone, whether there is a sense of commitment, and then after that, it's like half the people stay. Uh,
Okay.
um, Yes. So Ryan, quick set of logistics on that. The first few sets of classes will be on Zoom. Monday will be in person. I'll be on campus again. And then the next 2 weeks, I am in the ocean, so I'll be teaching, and we'll be teaching oceans, and I'll be in the ocean. So those will be on Zoom. But after that, we will all be in person, while the international students will be on Zoom. I do love the idea of sitting in person. It just so happens that currently I'm still in the field. I'm returning back, and then I have an expedition, and Enrico is actually also on that expedition. So the first 2 weeks we will be on Zoom. But kind of one of the threads that we will do is we will cover some of the framework, some of the theory side of the place. But then right after that, then everything else will be in person. I don't know, the class location is not listed on the website, but it's basically the UTL lab, which is in the BioE Shriram building, the dry lab. And we also have access to the wet lab because I'm very excited about the idea that this year uh, there is, I think my intuition is that there is a larger group on the wet lab side. So, which implies that we will open up some of the wet lab access. Uh, I haven't sent that. The Notion page, I'll send that as an announcement so that you can all join. And I think you will have access to the past Notion pages, but we will create a new 2025 section in it. And then also I will send out a Discord uh, link for everybody to join. And third thing I will send out is I will send out an advertisement for joining the class that any of you can send to any communities that you like. For example, John, you said you grew up in Central Valley. There might be a teacher there that you thought, oh, the questions that I'm interested in, I might do a project with one of my teachers, and that's perfectly okay. I think it's up to you guys if you want to recruit anybody that you really wanted to learn and build with. That's totally allowed. While I send it out to institutions that I have networks in. Okay, on that note, we are going to say goodbye. This was really, really fun. I cannot tell you how excited I am. And I think one thread also is that Discord, I will have direct access. So anybody can also write direct messages to me, but also Slack. I am a heavy user of Slack, as Kevin can attest to that. So private messages, just send directly Slack messages to me. Email, I don't really check. So please send Slack messages as the primary communication. And of course, I'm going to try using Canvas as the primary communication, just for broadcast announcements. And then I'll catch up with Kevin in terms of thinking about the list of things on our plate. So Kevin, if you can just hang in there for 2 minutes, we can have a logistics chat. All right, so I'll say bye to all of you. Walk around. I know you've been sitting for an hour or more.